Hello and welcome to the review of the topic rational functions, the second chapter in Further Pure 1. Let's look at the syllabus and see what are the areas that are covered under this topic. So the first idea here is to sketch simple rational functions. The graphs that you will be drawing need not be detailed. However, certain important features must be highlighted in your sketches, such as the turning points, asymptotes, and intersection with the axes. Asymptotes, you would have vertical asymptotes, horizontal asymptotes, also oblique asymptotes. In the second part of the chapter, we are dealing with some special cases such as y square is equal to f of x, y is equal to 1 over f of x, y is equal to absolute value of f of x, and y is equal to f of absolute value of x. You'll be asked to sketch these. Also, you may be asked to work out the inequalities and find the range of the function. Now let's look at the steps that we need to follow when we are sketching a rational function. The first step is to identify where the curve crosses the axis. The next step is to identify the asymptotes for the curve, horizontal or oblique, and vertical asymptotes. Then we need to identify the behavior of the curve on either side of the asymptote, whether the curve tends to positive infinity or negative infinity when it approaches the asymptote. Then the fourth step is to see if the curve will cross the horizontal asymptote. This happens when the degree of the denominator will be 2. Then the next step is to find the range of the function and the location and nature of stationary points. Let's take this example and sketch this curve using the steps that we saw in the previous slide. The question that is given to us is y is equal to x plus 1 times x minus 4 divided by x minus 2 times x minus 5. The first key feature that we are finding is the horizontal asymptote, which is y is equal to 1. The next one is the vertical asymptote. There x is equal to 2 and x is equal to 5. We have the intersection with the axis. The curve crosses the y-axis at negative 4 by 10 and the x-axis at minus 1 and 4. Now, if we look at the given curve, we have the x squared in the denominator. Therefore, the curve will cross the horizontal asymptote. We use y is equal to 1, we equate that the function that is given to us, and we identify that x is equal to 7 by 2. Now that we have all the features that we need, we can start to sketch the curve. So as you can notice here, the intercept with the y-axis is at minus 4 by 10. With the x-axis, it is at negative 1 and 4. The curve crosses the horizontal asymptote at 7 by 2. If you notice the behavior near the asymptote, when x tends to 2 minus, that when we approach x is equal to 2 from the negative direction, the y tends to minus infinity. When x tends to 2 plus, then x tends to positive infinity. The same thing happens when we approach, when x tends to 5 minus, y tends to negative infinity, and when x tends to 5 plus, y tends to positive infinity. So hence we have accounted for all the key features. We've accounted for the intersection of the axis, the intersection with the asymptote, the values of horizontal and vertical asymptote and the behavior of the curve near the asymptote. So the sketch is now complete. Now let's look at the first special case. We are trying to sketch the absolute value of the function. The given curve is y is equal to f of x. We are asked to sketch y is equal to modulus of f of x. Then we would consider two cases. When f of x is greater than or equal to 0, then absolute value of f of x is identical to this. But when f of x is less than 0, this is then reflected in the x-axis to get y is equal to absolute value of f of x. Now if you are asked to sketch on the other hand f of modulus of x, then draw the curve for y is equal to f of x and then reflect it in the y-axis. So two things to keep in mind. One is when you have the absolute value of the whole function, if the f of x is positive, then it remains the same, but if it is less than 0, it needs to be reflected in the x-axis. Reflected in the x-axis here. When you are sketching f of modulus of x, you sketch y is equal to f of x for x greater than or equal to 0, then you reflect it on the y-axis. Let's look at this graph to see how a sketch of y is equal to absolute value of f of x will look like. The curve that we have is sin x. We know that that is a wave function that is represented by the red color here. And the absolute value of sin x, you can see that any value that is below the x-axis gets reflected above the x-axis, and any value that is above the x-axis in the original curve remains the same. So from negative 3 to 0, the value that is below the curve gets reflected above for the absolute value of sin x, and the same thing happens here as well. Now let's look at the special case 2. We are given y is equal to f of x, and we are going to sketch y is equal to 1 by f of x. The zeros of y is equal to f of x become vertical asymptote for y is equal to 1 by f of x. The zeros here represents where it crosses the x-axis. The reverse will be true. The vertical asymptotes of y is equal to f of x will become zeros of 1 over f of x. When y tends to 0 from above, will become y tends to infinity, and y tends to 0 from below would become y tends to minus infinity. Now the reverse will happen. When y tends to infinity in y is equal to f of x, now y will tend to 0 from above, and y tends to minus infinity in y is equal to f of x, y will tend to 0 from below in y is equal to 1 by f of x. As you can see here, this is the reciprocal function, so everything gets reversed between f of x and 1 over f of x. When the function is greater than 1, then 1 over f of x will lie between 0 and 1, and when y is equal to f of x lies between 0 and 1, then 1 over f of x will be greater than 1. Similar rules will apply for negative values of y is equal to f of x. Key thing to note, the points on the line y is equal to 1 and y is equal to minus 1 do not move. Let's take an example to see f of x and y is equal to 1 by f of x. This is a quadratic function, 2x squared minus 6x plus 4, and it passes through the x-axis at two places, 1 and 2 right here. And we saw earlier that the zeros of the f of x will become vertical asymptotes of the 1 over f of x. As you can see there, you have a vertical asymptote here, and you have another vertical asymptote here. Then the vertical asymptotes of f of x will become zeros of this. So as you can see, you can consider this line to be a vertical asymptote of the graph. It would continue to widen as we go further up, so that hence you see that the value approaches 0, but then the x-axis is an asymptote for this. And also where the values that lie between these two roots, then when for y is equal to 1 by f of x, then it gets inverted, and then you get negative values here. So that's an example of sketching f of x and y is equal to 1 by f of x. Now let's consider the special case 3. We are trying to sketch y square is equal to f of x. So the first step is to delete all the points where y is equal to f of x is below the x-axis. The next step is to identify where the original function and the y square function will intersect. The next step is to identify the stationary points for the y square function, and you will notice that the stationary points of the original function, the y coordinate of that, will be the same for the y square function. Then the next step is to look at the gradient of the point where y will be equal to 0. Unless the gradient of the original function is 0, the tangent at these points is parallel to y-axis. Next, we can sketch the parts of the graph that are above the x-axis.